A herring swimming in the North Sea, crabs scuttling across the Barents Sea, or an anemone fish nestled among a coral reef. Biologists often conceptualize the natural world in terms of distinct species, each with a unique role in the intricate food webs woven throughout ecosystem globally. But that is surely too simplistic thinking. NIOZ researcher Anna Bontorjos is colleagues wrote in this month's cover story of the scientific journal Trends in Parasitology. If you ignore the different parasites that live in and on an animal, you might draw very wrong conclusions about its ecology. Born Torres said wild-caught animals should not be considered single individuals but rather as entire ecosystem by themselves, hosting a variety of microbes and parasites which can be found in virtually every tissue. Fish, crabs, snails, and other animals can be infected by a multitude of parasites. These include nematodes, cystodes, terators, isopods, or even copeptodes that spend part of their lives in the gills of fish. This parasite can affect the morphology, the behavior, and also the metabolism of animals in many different ways, said Bond Torrijos. Yeah, that way, those parasites also influence where an animal fits in the local food chain. When Bond Torrijos depicts the food chain as a slowly ascending graph, algae and plants as so-called primary producers which convert sunlight into edible energy are in the lower left corner. At the very top right of the graph are the top predators such as seals in the Barents Sea. Where other animals lie along that line we can determine by looking at the stable isotopes of nitrogen. For example, the researchers explains because with every step along the food chain, the heavy isotopes in that animal's pole of nitrogen accumulate a little bit, thereby indicating who is eating who in the environment. In the review article, the researchers describe how an animal's stable isotope values may differ depending on whether they are infected with parasites or not. That's because parasites can change the behavior of a host even without making that host really sick. For example, a coral fish infected by a specific species of isopod appears to forge much less outside the reef than uninfected individuals of the same species. This is then reflected in the chemical composition of the animal. Beyond the report.